what do we have here? We have a schematic of what you're going to be building. This here is so you can learn about the differences in the gates, and you actually can see it and see a truth table actually happen. So what you're going to wind up doing is on your breadboard, and I'm going to pull this out over here for a moment. Here we go. So you've already built all of this, including the binary decimal hexadecimal converter. I wound up stripping a whole bunch of extra power jumpers. I highly recommend you keep all your wires. You're going to use them over and over anyway, so it takes long enough to make this stuff. So just save it till you're all done. Put in a little baggie. You got two baggies in your kit. You can put the short wires in the little baggie there. So these are all 10s as far as length goes. So the next thing we did is I pulled out these chips. So you're going to need 4 chips. I'm going to put this one in just a moment. Let me zoom in here. So you're going to need, the first one is this here is a 7404. This here is a 32, which I can easily read. This here is the 08, and this is the 7400. So whatever the part number is, you already learned how to read these. So you see how this one says 74HCT. Ignore the middle numbers, or the middle letters, and the first 2 letters, and the thing on the end. All you're after is 7400 and then the number on the other side. You may have LS's, HC, HCT, ALS, F. There's a whole bunch of them out there, and even C. Mostly you're going to have HC and HCT. You might have a couple LS's. So this here is a 04, a 32, an 8, and a 7400. I already placed the jumpers in here, power and ground. Remember, 5 volts goes here, and ground goes here, or low, high and low, high and low, high and low, and then on this chip here, high and low, and they go on the diagonals. This here is the only chip that has the power backwards. So don't wire it up this way. Please wire it up correctly. And on this schematic here, I bring that up as well. So for these chips here, they're all 14 pins. So pin 14 is 5 volts, and pin 7 is ground. If you have a 16 pin chip, pin 16 is 5 volts, and pin 8 is ground, because that will be on the 2 diagonals of the chip. Alright, so let's talk a little bit about what we're going to wind up doing. So you're going to hook up switch number 4 and this one to the first LED, and then switch number 4 on pin 1. So this here shows pin 1. You see pin 1 there, and that tells you the part number. So pin 1 gets switch number 4, pin 2 gets hooked up to your LED, and I show you that in a more direct version. So the reason why I chose switch 4 is because it's the lowest bit on bank number 1, and I'm referring to this. So this is switch number 4 right here, and this is switch number 8. So this is bank A, this is bank B, and this is bank C. I want you to think in terms of nibbles when you're working with this stuff. It will actually help you, especially since you're going to be going into microprocessors. So this would be the high nibble and the low nibble, you could think of it, and this would be a control, or ABC. So you're going to be using this one, actually you're going to be using this one and this one. So you're going to plug in here and here, and you're going to wire all of them up. I do this a couple different ways to show you how 5 volts is described in schematics. You could have this. This is not a very common description. It's going to be more like this, or an open or a circle. but 5 volts goes here, and then this is the 1 kilo ohm resistor, which are these here. So you have 5 volts here, and the 1 kilo ohm resistor is here. Then you go into the chip, pin 1, and then this is the output, which will go to the LEDs, and then the resistor, which is exactly what you have over here. And then on this one here, on this chip here, so you're going to come out of the switch into pin 1. So out of this switch into pin 1, which is this pin right here. And then you could do a couple things. One is you could daisy chain it to here, or you could bring it to here and then daisy chain it. Remember, you got a whole bunch of leads to work with, or holes to work with. You have 3 holes here, so you're going to wind up daisy chaining one of them. So pin 4 to here, switch number 4 to here, 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 and here, which is pin 1 on this chip. On these 3 here, you're going to go from switch 8 to pin 2, and pin 2 on the part. And then we're going to wire up the LEDs. This here is pin 2. They're going to go to the first LED, which would be right here. And then this one here from pin 3, as shown right here. Let me slide this in. So pin 3 on all the rest of these parts are going to go. So pin 3 is going to go to this LED. This one here, pin 3 is going to go to this LED, and this pin 3 is going to go to this LED. Alright, so now let's do the build. Alright, so this here I need to straighten out. As you can see, it's not straight. So remember, when you straighten parts out, you roll it gently, just a little bit on each side. So see how they got that one straight? And then over here we're going to do this one. And as a reminder, you got to look for pin 1. You got to know where your pin 1 is. So on this part right here, you see that? That right there is pin 1, that notch. Sometimes you'll have a notch, sometimes you have a dimple, sometimes you'll have both, but you'll always have an indicator that pin 1 is. Now you got to be careful, because you see that little circle right there. Let me see if I can get the light to reflect on it. That little circle right there, that reflected just a moment ago. There we go. So this little circle here is not, it doesn't mean anything. That's how they made the plastic. Now, something I want to point out, you see the pins are slightly bent. That's because I'm handling it a lot, and I didn't have enough foam. As a reminder, make sure you get rid of your static, especially during the winter. If you have static, these chips will go poof, and you won't even see the genie. They'll just die on you. So you see, I just used my needle nose pliers very gently and bent it straight. And now I'm going to put this on the 25. So I staggered these every little bit. So this is 5, this is 15, this is 25, and this is at 35. Ignore these numbers are backwards on this one. As a reminder, you got to put the jumpers in if you have this type of board with a stripe missing. Otherwise it just won't work. Alright. Now I'm going to hook up power and ground. No. This here is an awfully long wire. Doesn't really matter. Ground, you don't use it too often. So that's an awfully long wire. Don't do that. And this one here is going to go to here. Okay. So, as a reminder, make sure you don't have any cuttings on your board. I'm going to give it a little tap to clear it out, and nothing fell off. Move these out of the way, and now we need lots to wire colors. So I have blue and white. You remember I was telling you about the Cat 5 wires? So you can use these, especially when you're doing, in your next lab, you're going to be using A and A prime and B prime. You can start using these. You can start using these for that purpose. So I'm not going to use a white wire, I'm going to use a blue wire. You have 10 wire colors, 2 of them are reserved for power and ground. So definitely do it in different colors. I would even recommend you take, Dr. Petrie recommends that you take and use colored pencils to draw in the lines that you're working with. And I definitely agree with that because it really makes troubleshooting easier. So, how about green? Okay. These don't have to be tight. Tight is better, but it don't have to be. So, I'll plug this one here. Remember I told you I was going to daisy chain them, or they could be daisy chained, so I'm going to do a little bit of both. So all of these are going to go to pin 1. And so, did you see what I did? I put it in the hole and then I used my fingernail right on the line and then bent it up, and that's going to give me this. So now I'm going to cut it at about a 3, and that is where I'm going to strip it. So let me go ahead and get these 2 done. Okay, it doesn't quite matter which set of holes you put them in for the ones, but there you go. For some reason I'm having trouble with this. This is a used breadboard, and someone wasn't very careful with it. And I'm gonna do this. I know I could go from here to here, but I'm gonna go from here to here just to show you that it can be done. Doesn't matter as long as they're all connected. So now all the ones are connected together. Okay. All the ones are connected together. So just to go over this in the schematic, here we go. So 1, 1, 1, 1 is all connected to switch number 4. Right? Or here, switch 4, switch 4, switch 4, switch 4. Okay. So now we're going to do these three, which are your OR, your AND, and your NAND gate. Those are all going to get connected to switch 8. And for that, I'm going to use, for some reason the blue wire says use me, so I'm going to use the blue wire here. So I'm going to go from this one over to here. That fell nicely on the floor for me. Okay. And so we're going to go from here, go from here to here. Looking pretty good. Getting a little busy here. Now you can see why it's important to use different color wires. And I am going to go from here. Find one that's going to work well. There we go, that one worked. So now I have all the 2s connected. Just to review, switch 4 are the greens, so I have this one here, here, green here, and green here, all going to the 1s. Switch 8 are going to the 2s, so 2 here, 2 here, 2 here, and those are the blue. So I got a blue here, a blue here, and a blue here. Now we need to hook up the LEDs. So the NOT gate, or the inverter, we're going to come out from pin 2, and then on these 3 here, we need to come out on pin 3. And I'm going to use different colors for each output, because those are different, totally different signals. So it's important that you keep, when you have a different signal, use a different wire. So that way you can keep track of it much easier. So the first one will be a white. So that one's going to come out of pin 2 on the inverter. Can't quite see it, but I don't know what they did to this board. So, alright, so we're going to plug into, sorry, I got my big finger in the way, big hand in the way. So we're going to plug, see the resistor? Not where the resistor is. That's the positive side of the LED. So this white wire is going from pin 2, which is, and then into the odd side. So it's going right there. Okay. And then I'm going to use a yellow wire. Again, it doesn't matter. The electrons don't care what color color the insulation is, but it does care that it is properly insulated. So I got my big hand in the way. I'm looking for a hole that's going to work. There we go. And I'm going to come to the next one. So I'm going to go into this LED, and I'm going to go into right there. I'm making the wires a little long, but that's more for demonstration purposes. Remember, make sure you, how long do you strip it? 3. So by the time you get to be doing this next couple of labs, you're going to be an expert on the length of stripping wires. And let's see, that looks like a gray, so how about a purple? Okay, so that's pin 3 on the 3rd chip, and that's going to go to this LED right here. So remember, not where the resistor is. And I have a gray wire. So the outputs of each gate would be your midterm or midterm midway part that you would be doing stuff with. And let's see here. There we go. What is this little red wire doing here? I don't know. Alright, so let me shake off all my wire strippings. Alright, so I had a few wire strippings right there fall out. Alright. So, to review, we have switch number 4 going to all the pin 1s. Okay, those are the green wires. The blue wires is coming out of switch number 8, which would be this would be the A bank, and this is the B bank. So this is A0, and this is B0. And so B0 is the blue, and that's going to pin 2 on this chip, and this chip. This is the inverter, this is the OR, this is the AND, and this is the NAND. And then the output of each of the gates. So on the inverter, it's only one input, one output. So this here is pin 2, that goes to the first LED. This here is pin 3 coming out of the OR gate, going into the second LED. The AND gate, pin 3, goes to the third LED. And the NAND gate, coming out of pin 3, going into the fourth LED. Alright, so now we have everybody turned off. So what do you expect to see happening here? You remember what your truth tables are? So let's go with a truth table for this stuff. So the truth table, I'm going to move this over here. So the truth table here is if you have a 1, if you have a 0 and a 1, A, and this is, we're going to call this Z. So A, this is an inverter, so this is a 1 and that's a 0. This here is A, B, and Z. So what happens here? You got a 0, 0, 0, 1, 1, 0, and 1, 1. What goes on here? So this is an OR gate. So if this one or this one are high, then this is going to be on. What happens if both of these are on? This one's also going to be high. There's a special OR gate where you do this in front of it, it has two curves in front. That's called an exclusive OR, which means only one of the two can be on. But this is not an exclusive OR, and we don't have one of those in your kit. I might consider putting one of those in your kit. If you want an exclusive OR, go find one in Lab 205A. They're in the drawers. You can pull one out of them. You can play with it. So this is low and this is low. Is this going to be high? Is this going to be what state is Z? State of Z is going to be low. One of these two is on, so that's going to be on. One of these two is on, and one of these two is on. Actually, both of them are on, so that's going to be a 1. All right, and means this and that have to happen. So this is an AND gate. It's a flat line right there. So both of these have to be high for this one to change. So A, B, Z. So we have 0, 0, 0, 1, 1, 0, 1, 1. So what's happening here? Are both of these on? No. Both of these on? No. Both of these on? No. Both of these on? Yes. Now, we can take this for the NAND gate, and I'm gonna come over here. So we're gonna call this is a NAND. So we're going to use the same truth table, but we're going to call it not Z. So a NAND gate is really an AND gate pumped through an inverter. So the question is, when this is low, so this is going to be high. This is low, that's going to be high. This is low, or that's going to be high. And this is low, because this one's high. So the way to think of this is you're going to get the next state, because this really is okay. That's what's going on there. That makes sense? All right. Now, something to know, this was the first chip that was just called the 7400. They only had these in the mid-60s. This was one of the first chips out there. You can build everything in this chip. It's not pretty, and it's a lot of parts. I've done repair work on equipment built with the NAND gates, and it definitely will give you a headache figuring this stuff out, but we can do it. It has been done, and for those of you who don't know what Pong is, this was the main part in Pong. And I built a Pong game. My uncle had bought it for me, and the two of us soldered it for days. And believe it or not, the thing worked. I could not believe it worked. He was really surprised himself. Then we played Pong quite a bit. So you can build a lot of stuff with this. It's not fun, but it is possible. Alright, so now we know what to expect. Let's turn the power on and see if we get what we're going to expect. So power is on. So first question is, which two do we expect to be on? So the inverter, because both switches are off, this one and this one are off. So the inverter, which is the first one, and the NAND gate should also be on, because they're both off. Okay, so we're going to turn this on, and what do we expect? The NAND gate to be on, and the inverter to be on. So these two will be the first ones that turn on. So turn it on, and voila, congratulations. Now we have, going to turn this on and watch what happens. This is the OR gate. So the OR gate is this one or this one are on. And let's turn this off. And you notice the inverter came back on. And then You notice the NAND hasn't changed yet. So again, the OR gate kicks in because this one is off, but this one is on. And now we're going to turn them both on. And this one should turn on, this one should be on. And the inverter will turn off because that was the one driving the inverter. And look at that. So this is the OR gate, now the AND gate kicks in. And did you notice the NAND gate turned off? So I'm going to turn this one on. Okay. So congratulations, you have now seen your gates, your basic gates in action. And thank you very much. Definitely has been fun. I've enjoyed doing this and helping you folks out. Okay.